Welcome to the Industry 4.0 Club's Fireside Chat. The club's purpose is to engage the power of diverse, worldwide talent to accelerate the global evolution to Industry 4.0. The club accomplishes this by hosting and supporting respectful, insightful, thoughtful, and interdisciplinary open conversations and creating quality content on wide-ranging Industry 4.0 topics to expand the reach of our community. So my name is Mike Ungar, and I am the CEO of the Industry 4.0 Club. I have over 40 years of leadership and experience, with most of that time being spent with Michelin North America. Today, we're joined by my co-host, Mike Yost. Mike, would you introduce yourself, please?
Absolutely, Mike. Thank you. As Mike said, my name is Mike Yost. I am the volunteer chairman of the Industry 4.0 Club, one of its co-founders. I've been in industry for about 35 years and am really excited to continue the conversation with David as we had him on with us again previously last week.
Thanks, Mike. So we're joined also today by David Ariens. He's the author of the IT/OT Insider and a manager at Analytics for Industry. Last week, as Mike said, David shared his insights about the IT/OT convergence. And today our broadcast is entitled, It's the Platform, Breaking the OT Data Barrier. So David's joining us from Antwerp, Belgium. He holds a master's degree in mathematical engineering from KU Leuven. He was previously the Industrial Digitalization Director at BSAF in Antwerp, where he focused on building digital product teams and sound cybersecurity practices. Today, he leads analytics for industry as an advisor to Timesia.ai. His focus today is on IT/OT convergence and designing operational data platforms for his clients. He also publishes the IT/OT Insider with Willem van Lammeren. So welcome, David. We're glad to have you back.
Thanks for having me again.
Yeah, it's great to see you. So last week you shared your journey from getting your master's degree in mathematical engineering to become an expert really in IT/OT convergence. This week, could you share how did you develop your interest in data platforms?
So last week I mentioned that I did a master thesis around model predictive control. So I used at that point in time fancy tools. I worked in MATLAB, in Java, all the languages, all the tools well, in my opinion, that was what the world was about. And then I joined BASF, and I basically started using Excel again. There was nothing else than importing data in Excel sheets and maybe writing a couple of lines of VB code. So it's this. There are a couple of memes on the internet where while you're studying, you're using more and more advanced tools, and then at a certain point in time you go to the reality, and suddenly you go back to the basics, right? So that also happened to me. So right from the start, I was faced with this dilemma of I want to build certain models, but I needed to fetch data from all different sources. I needed to sometimes even manually input data. I saw that in the introduction video, you had this 3D simulation of a turbine. And that actually it resembled one of the projects I did where we were predicting turbine failures. But all honestly, I would say the mathematical part or the modeling part was actually the smallest part of our project. The difficulty was everything which came before it, and I would say that basically ignited also my interest in how to work with data, how to scale data, et cetera, et cetera. So those were the early days.
No, thank you for that. That's interesting. So I know we started with the term data platform, and when I was with Michelin, I kept hearing the term data lake. Can you define data platform, and is it a data lake, or how do those terms relate to each other?
Yeah, absolutely. So first of all, when we talk data, I think it's extremely important that we make a distinction between talking about more IT-related data sources or more OT-related data sources. Now, there are people who say like data is data, but I don't really agree with that. So here we're talking about OT, sensor, IoT-related data sources, and that's time series data. That's time series data, I would say, in its as a starting point. And then best case, but we'll come back to that later, I guess. Best case, we also have context, etc., etc. But it starts with time series data. Now, time series data is something which is very it's a special kind of thing, right? A special kind of data. It flows in whenever it flows in, sometimes every second, sometimes every minute, sometimes maybe not a data point in a day and then something else. There is also not really I would say, a fixed structure in place. It just flows in. And what we see is that when we talk about these data sources, it's still commonplace, but typically this data gets stored in a data historian. It's a piece of software which runs somewhere in a plant or somewhere in a corporate data center. In some cases, somewhere in the cloud. And that piece of software is really designed to store sensor data at scale. But, and this is really, really important, also to be able to access that data in a very, very efficient way. One of the examples I always give is, suppose I have a counter value, and I want to calculate my energy consumption from the last day, the last month, the last hour. When I have a good data historian, I do not need to fetch all the raw data points in between. I can just fetch the first one for my time frame, the last one, and then I can easily calculate the power consumption in between. Well, if the historian is up to it. So when we talk about time series data, we have this special kind of thing. If we take a look, or if we take a step into the IT world, when we introduce the concept of a data lake and a data warehouse, what is a data lake? A data lake is, I would say, it's a collection of all kinds of different data sources, raw data sources from all types of places. Can be the ERP system, can be tickets, can be logs from the websites, whatever. A data lake is where we put all the data in without having structure already in place. It's just raw data as it's, I would say, living in my other data sources. And then when we talk about the data warehouse, that's where we take that raw data and we do some manipulations on top of that to start combining data sources and to start making reports which are more or less ready to use. So that's from the IT side. Is OT data a data lake? It resembles that a little bit, but I think in essence, it's still two different worlds, two different types of data.
That's interesting. Guess I didn't realize that we had so many definitions and things that we call different sources of data.
Yeah, Mike, if I could just jump in, I mean, I think it's an interesting point too, and I think there's a lot of confusion and questions about, do we just capture everything, shove it into that data lake, and figure it out later, right? To the point. And so I guess, David, maybe two questions. If somebody comes to you and says that's our approach, right? Do you recommend that kind of an approach, or how do you respond to somebody that is just thinking, we don't know what we're going to do with the data, but we're just going to collect everything that we have and shove it in a lake and figure it out later?
Yeah, bad idea. There are a couple of reasons why that's a bad idea.
Yeah. Could you be more clear?
Yeah. More direct.
No, just a bad idea, Mike.
Yeah, there we go.
No. There are definitely a couple of reasons why that's a bad idea. So first of all, I think it's important to understand that most systems, I'm not saying all systems, most systems, most software which today is used to build a data lake is not really up for the job to also have time series data added to those data sources as well. It's because not because you can't. Typically, you can store the time series data, but what I see in reality is that these systems, they still have it's still very difficult for those just all kinds of different software here. I'm not going to name drop any of them, but typically it's very hard to get the data out of that data lake, just because of the fact that time series data is a special kind of data to work with. So first of all, what I see is that while it's typically easy to store data in a data lake, especially for sensor data, it's still rather difficult and thus compute intensive and thus costly to get the data out of that. And that brings us immediately to the second point. What I see when companies, they start just dumping IIoT or OT data in data lakes is one of the first things they always come across is the cost perspective. Because that can blow up really, really easy. OT data historians, they are very good, very well optimized in storing data as, I would say, as optimal as possible. For example, something like delta storage, where we only store differences. We don't really store the raw number every time, or compression. So when you take the same data sets and you upload it to a data lake, what we typically see is that the storage required sometimes explodes. So from a cost perspective, it's also not a good idea. And then thirdly, and that's of course the most important reason, is what's the use case? And what you typically see is people they dump data in the data lake, but they don't really consider the use cases. Who is going to use that data? How is the data going to be used? And if that's an afterthought, then typically you come to the conclusion that we have to go back to the drawing board. So my answer is always no by default, and we can also discuss it. I'm a big believer of these technologies as well. Yeah. So we need to do this in a way which we know what the desired outcome is going to be, and then we take steps towards that desired outcome.
Yeah, and so thank you for that. I guess the other question I wanted to throw out has to do with the benefits of having, and I think I heard several points in your response there about the value of a data platform. So could you talk about the benefits of a data platform for everybody?
Absolutely. I'd love to share a couple of things firstly while I'm talking. So Mike, if you could put on this diagram. This is just it's me trying to draw something. So forgive me the very rude picture, but what you see here on the top is typical sensor data. Sensor data, it's a temperature, a pressure, whatever. It doesn't really make, it doesn't really matter the context here, but it's sensor data, and there are a couple of things which you see already. First of all, the red dots, they resemble raw data points, and you see they are scattered around. The purple vertical lines is, I would say, are interpolation timestamps. And what you typically see is that once you start using data in, for example, an Excel spreadsheet or in Python or whatever, first thing somebody is going to do is always interpolate data, because in most cases you can't really work with raw data. If there is a data point once a day, or there's a data point once every 2 seconds, you need to first of all interpolate that data to be able to work with that. So these are the purple lines. Now, what I see from, I would say, most use cases when you start working with data is that this is what basically working with data is all about. You access sensor data, you interpolate it, and then you start working with it in whatever system you want to work in. The very first thing to make that data smart is to provide context. Now, what is context? Context is everything which goes around us, happens around us. And here I have two very concrete examples, being production context and quality context. Production context can be, for example, I was making a certain product, in this case, very nice Belgian waffles. It was a certain batch 1, batch 2, etc., or a certain process step. I was heating, I was baking. This is an example from foods, but even in continuous processes like chemical processes, you can actually do the same. But then typically your production context is spread out over multiple days, multiple weeks, sometimes even multiple months. An example, for example, can be a furnace run. The furnace runs for so many months, or the reactor runs for so many months. But the context is, this is one reactor run before I did, for example, a regeneration, or before I decoked my furnace or whatever. So that's all context from the production environment. You could add context from your shift teams, from your people. In this case, I'm adding context from my quality data, because every so many hours I'm taking a quality sample. And here is actually already a very, very interesting first problem. Is I'm taking, for example, a quality sample every hour, or every 5 hours, or every 6 hours. But here we have the question like, okay, if that sample is taken, first of all, where is data stored? Typically, your production context, your sensor data, your quality context typically are stored in different systems. But then also, if I'm taking a quality sample, what timestamp is stored? Is it the timestamp of the quality sample being taken, or is it the timestamp of the quality sensor being analyzed? So that's already a first problem. And then your second problem is, to which time frame does suppose it's I'm measuring viscosity or something like that. To which time frame does the viscosity apply? Hey, does it only apply to the period in time I've taken the sample? Or do I say, like, you know what, all data 1 hour before or 1 hour after also has the same viscosity? So there are all kinds of, I would say, decisions which you need to take.
Yes.
And David, just to interrupt real quick, I'm sorry. You mentioned in your previous answer about use cases, and is it safe to say that when you're looking at quality, you're looking at production as you're talking here, those are use cases, right? That people are trying to understand their performance and the viscosity levels, or quality levels, things like that, which then you put the context to the raw data to deliver against the use case.
Yeah, absolutely. Yeah. So it's predicting a quality, optimal quality, optimal energy consumption, predicting an upcoming failure of a pump or a turbine, as in your.
Well, yeah, and so what I hear you saying too is that there's an awful. You have to, in some cases, make some assumptions or define some rules by which you're going to interpret the data, based upon your knowledge of the process.
Yeah, absolutely. And so this is, I would say, this is step one. So this is, if I talk, for example, to IT people, to data scientists, I typically start with this story, because I want to explain to, and this is just the basics of the basics, right? We didn't even touch data quality or something like that, but I want to explain to them how different it is to work with sensor data compared to IT data, the data they're more used to, and also the problem that all these data points, or at least all different data sources, they are typically scattered around the place, and you need to do a lot of manual work to integrate these data sources. And so I always start with this one. And then I'm going to this slide. So what you basically,
I'm sorry to interrupt. Could you go back to that just for one quick second? Because I just,
sure.
We talked before, and folks that watch the show know that we work closely with a national institute in the U.S. called SESME, and I think people don't necessarily know what the heck it is as an organization or what they're doing. But I think this slide really brings a lot of it draws a good picture for the work that they're doing, and the importance, which aligns with what David is doing. And when you look at the fact that the sensor data there, the source data, could be used by different use cases, different applications, to define production, define quality, define costs, to define inventory consumption. All sorts of use cases come out of the use of that same data. Historically, those systems are sold by different suppliers. So you have a quality solution, you have a production solution, you have different applications that are either probably connecting to the same data sources and creating their own data repository to provide their own context. And so just to sort of connect some dots from everybody, and David, being in Belgium, you may not know SESME and their efforts, but just to support what you're saying from a data platform perspective, their work is really to help address this context layer and remove all of the heavy lifting and the risk of doing the plumbing for every single use case, every single solution in its own separated, isolated way, and instead have a standard approach for pulling data together, providing context, and letting different applications come and pull the information as appropriate. So I apologize for the interruption, but
well, Mike, let's maybe it'd be good to share. I mean, just for the group's benefit, if you're interested in learning more about what Mike was talking about, there's just SESME works really as part of a consortium to look at this topic, and here's a reference if you're interested in just learning more.
Yeah, and the International Manufacturing Exchange Council is another validation of the discussion that we're having here, that David's driving, the fact that there are multiple nations that are looking at how do you supply information and exchange information across the supply chain. And if you don't have a handle on this piece of it that David's talking about, it's really a problem that I'm not sure. I'm not exactly sure how you address. So it's nice to see that it's happening at a national level. It's now happening at an international level. And then I think, David, it ties into where you were going with the next conversation, that the IT leadership who's going to be involved in the supply chain conversations and moving data across the supply chain need to understand this foundation you're laying here as you have the next conversation with the IT leadership.
And to these points, so last week we talked about IT/OT convergence from the two silos, but here we actually have sub silos. Today, indeed, maintenance typically is a silo, quality typically is a silo. Supply chain, they are typically part of most organizations. Supply chain now is part of IT, but from I would say from a data integration point of view, they're also typically a silo. So here again, we need to somehow, bring these silos together. So yeah, absolutely. Very interesting thought. And as I also said last week, I see IT/OT convergence today mostly as data convergence. Why? Because typically today, IT owns the data problem. If we go back, let's say only just 5 years, right? If you had a problem which contained operational data, so it was, you needed sensor data somehow, then you would always go to a process expert. You would always go to somebody who understands operational data, because there was not really another solution. And today, what you see is that, driven by all these data platforms, driven by artificial intelligence, etc., you see that IT starts to own a data problem, but they now also need sensor data as well. And then I'd like to go back to the slides I wanted to show just before your intervention, Mike. Is that if you take from a helicopter point of view or satellite point of view, how is the data? How do you, I would say, execute a data-driven problem? So here I have 3 data use cases. Can be done by one data scientist. Might be done by 2 or 3 data scientists. And so the first, they always do the same thing. And I also did that in the first years of my career. So it's first about finding the relevant data, about integrating manually or with some scripts, integrating data sources, cleaning data. We didn't really touch the cleaning point, but that's it's super time it's super time intensive, especially in those industries where you also have regulations about data quality. And then at a certain point in time, you're going to start your analysis. And I don't know the exact, well, actually I do know the exact percentages, especially, well, for the people I knew, because I did a small mini research thing a couple of years ago, where I asked data scientists, can you please somehow, roughly speaking, let me know how much time you spent in the first part and how much time you spent in the last part. And at least 50%, and sometimes even 60 to 70% of their time, they're working on the first part. And they do that over and over and over and over again. So it doesn't really scale.
To support that, in the US, the industry accepted percentage of how much time in a project was spent on the front end work to add context and such was 85% of the time was spent on that front end work. Yeah. So that definitely supports your.
So it's even an underestimate from my side.
Yeah.
And then you also have the difference between data scientists who are, I would say, working already for several years within a certain context, so they know their data sources and they know the people they have to talk to, or people who are more new to the job and need to figure it out while they go. So, and what that basically that results in something really problematic. And then we come to this graph, And what I wanted to show here is that on the horizontal axis, on the x-axis, I've plotted, call it, I basically plotted dollars or euros. So I plotted budgets, people,
resources,
time, resources. It's the resources you have, the time you spend, basically the dollars or the euros you spend on your data science teams, on your data science engineers, on your data scientists. And on the vertical axis, the y-axis, I plotted I would say the number of successful projects. Now, what you want to do I would say in the normal world is, if you spend twice the number of resources, you hope to get twice as much results as well. So you want actually to have at least a linear scalability of your data science teams. But what I see in many industries, and I face it myself as well, is what I see is the red line, which means that the more companies start scaling out their data teams, the slower they get. And it's not just about the people, it's about they start connected to more data sources, they want to do more fancy things, they implement new systems, etc., but they typically start to slow down. And why is that? That's exactly because of the previous picture, because the more data sources you get, the more people you get, the more complex it becomes to always do that job over and over and over again. And that's a big problem, and we should actually aim for the opposite. And this is where now the data platform idea comes in. What you want to have is, you want to create a scaling, a way to scale. If you take a look today to the IT world, in the IT world, Midjourney or DALL-E, they are run in the beginning. Midjourney was run by how much? Like, I don't know, 20 people or so, but they reached the entire world. Why is that? Because they have scaling possibilities. Now in OT, we will never be able to scale that intensively, but this is where the data platform comes in. And what I actually wanna do here is, I want to convince people that what they want to do is they need to spend time in contextualization. They need to spend time in doing that once, and then storing that knowledge in the platform, so for other people to always be able to build upon these learnings.
Yes.
And the thing you want to achieve here is that data use case 1 still takes some time, and 2 a little bit less, and 3 a little bit less. You actually want to reduce the preparation time as much as you can.
So David, that makes a lot of sense. One of the things I'm thinking about, so for our listeners that are listening to us talk about this, and they've already started down working with a data lake, or they've done something and they go, oh no, okay, what am I going to do? How do I get from where I am, which is a mess, to what David's talking about? Can you talk about folks that have already started, and what are your thoughts on, okay, how do I get myself to where I'm much more efficient than I am today?
Yeah. So there are a couple of things here. First of all, first question you want to ask yourself is, do I already have an actual operational data platform? Which means, do I have a data platform which is able to work with sensor data in a native way?
So putting that in place, regardless of where I've started, from this point forward, makes a lot of sense. I hear you saying.
Yeah, because what I see is, if your data platform, I would say, if the basic technology from your data platform is not able to work with time series data in a native way, then you will always be custom scripting, custom coding. You will always be trying to solve problems which you shouldn't be spending time in. So the first thing is, do you have a system which is time series native? And there are a lot of possibilities on the market today.
Okay.
Then the second question is, how can I start integrating as many data sources as possible within that data platform, but do that in a use case driven way? Just don't have a team of people whose job it is to integrate data sources just for the sake of integrating data sources, because there always needs to be a purpose, right?
Yeah, some problem we're trying to solve.
Yeah. So okay, now I'm trying to solve a problem, and we need quality data. Okay, let's start integrating some quality data as well. So you need to be able to integrate several data sources. Then that also requires you to think about, where do I store the truth? This is really important, because from a company perspective, you need to decide, I'm storing the truth in this or that system, because you always have, most companies, they have for legal reasons or for whatever traceability reasons, you need to do certain things and you need to report on certain things. But you want to actively decide where you store the truth. Which are my users consuming data from the data platform, or are they still via some kind of a backdoor consuming data directly from the original data source? So that's also really important.
Well, David, that would you brought up AI earlier, and that's at the tip of everybody's tongue nowadays. If people are thinking about an AI strategy as well, I would think that it plays into the points that you're making right now.
Yeah.
Is that accurate?
Absolutely, because this brings me to the second point, or the fourth point already, is that you need to start integrating these context things. And what I've shown you earlier: maintenance context, quality context, production context, etc., etc. But also asset context. Where does this data point belong to? Does it and then of course we can refer to ISO 95 or something like that as a model to model your asset context, which is still very good, I would say. There is no reason to doubt these existing asset models, but you also need that asset model. And then from an AI perspective, and these are, I would say, in the beginning, these are the most important steps. What you could also still add is data quality. I'll get back to that in a second. If you have the context, if you have several data sources, here again, do you wanna integrate every single piece of context from the beginning? No. Also, again, do that use case based. And then finally, and this is the dotted arrow here in this diagram.
Yes.
Also, feedback learnings into the data platform. If somebody built an interesting model, feed that back into the data platform for others to use it. Now, if you take a look from an AI perspective, what does AI need in order to be successful? AI needs good data, qualitative data, but it also needs a hell of a lot of contextualization, because that is only when you have contextualization available, you're able to actually use AI at scale. So I would say, Mike, as an answer to your question, AI models are definitely use cases of an operational data platform, but because they need qualitative data, they need contextualization. What I see is that if you can do that, you can really speed up these projects.
Wow. Man, so Catherine, we've been talking for half an hour now, and boy, you've kind of taken us kind of through an awful lot. There's an awful lot that I've taken away from this conversation, for sure. It's and it's interesting because when you get this right, the power of that seems just tremendous for a company in terms of improving their results. So that's really neat. We're getting ready to go ahead, David.
Yeah, I just wanted to name drop one specific thing, that's the unified namespace.
Okay.
Unified namespace is also unified namespace is not a competitor of what I'm talking here. The unified namespace is exactly what we've been talking about here. So what you see is that and of course there are some, every vendor has a certain implementation, but what you see here is that because you want to have this unified access layer, every user, every application can consume. This is exactly what you want to do, and of course how you do that, and again to the why, what, and how from last week as well. How you do that, there are several ways to do that. To do so, there are several vendors today. What I do see is that this is a domain there is so much going on right now. There are a lot of vendors, bigger and smaller ones, startups, but also all the big names, they are investing enormously, an enormous amount of resources in this topic. What I do see today is that we are still, I would say, we are taking the first steps right now. There is not a fully, perfectly ready, integrated operational data platform available today. It's still, you still need to combine certain elements. There is still some manual work to do, or you need to combine vendor A and vendor B. There is also some confusion in the market. But I think this is, I would say, it's a future state we should be aiming towards, and which I would say also vendors should be aiming to build towards that future state.
That's great. Well, we're getting ready to wrap up. We've had a really great conversation now for the last 30, 35 minutes. Mike, final thoughts from you?
Yeah, it's a daunting conversation, right? That's been going on for some time, and we talked about the fact that there are resources available, like David and his team, from a thought leadership perspective, national, international initiatives underway, and I would say that my takeaway is that, as daunting and overwhelming as that can feel for folks, David's point about focusing on the use case first, I think, is really the answer, right? That you know what business problems you're trying to solve, you know what plant production problems you're trying to solve. If you focus there as your starting point, you can get your smart people, whether they're internally or externally, to work with people who understand the data side of things. But if you're not starting with the use cases, you're not leveraging the process knowledge and the business knowledge of your operations, then you're going to end up probably making mistakes that could be rather costly. So for me, my main takeaway is focus on the use case, the business problems you're trying to solve, and we can work through the rest of the issues from a data perspective.
Yeah, thanks, Mike. David, any last thoughts as we wrap up?
Focus on the why. Make sure you create the needed buy-in from the management team. Forget about initial return on investments. You cannot calculate an ROI of a data platform. You just can't. You need to focus on the why. You need to focus on the use cases.
It's foundational, isn't it? Yeah.
But you do need to invest in the foundation as well. IT/OT cooperation / convergence. This is only going to work if you cooperate between the silos, because you need to have the time series knowledge. You need to have the process knowledge, but you also need to have the data platform knowledge, the cloud knowledge, the data science knowledge, etc., etc.
Thank you for that. So really would like to thank Mike and David for joining us for this insightful discussion about data platforms. If you're interested in learning or hearing more learning more about David's insights, he does have a blog called IT/OT Insider, and this is where you can access that. So please, if you want to reach out and learn more from David and just stay in touch with some of his thoughts, that's where you can pick that up. So thanks, David, for that. And thanks to everyone who's joined us in the audience today. Hopefully you've walked away with something that you didn't know before this the broadcast. We're happy that you've joined us. So if you like these sorts of Industry 4.0 Club conversations, we host these on Tuesdays and Wednesdays at 12:30 p.m. Eastern Time, which is, of course, 6:30 p.m. Central European Time. And we do that on really around 4 different topics: women in manufacturing, and then the future of manufacturing, which is a technical topic related to Industry 4.0, fireside chat, which is similar to what we've done today, highlighting an interesting individual like David and their background. And then finally, people, process, and culture. You can also follow the club on LinkedIn or on our website at www.industry40club.com. Mike, David, thank you guys very much for joining us, and I wish everybody a great rest of the day.
Thank you very much.
Thanks, David. Thanks, Mike.
Thanks.
Bye-bye.